Hi, 7th grade. Welcome to lesson 6.3, Make Comparative Inferences About Populations. By the end of the lesson, I want you to be able to say, I can draw comparative inferences about two populations using median and interquartile range. Let's explore it. Ella surveys a random sample of 20 7th graders about the number of siblings they have. The table shows her survey. So she didn't want to write the student's name, so she just put student A, B, C through T. And then we've got numbers of siblings. So I want you guys to organize the data, and we'll ask for some participation on how we can draw a model to show how Ella can best display her model or her data. Okay, so maybe we got a dot plot. If they had 0 siblings, there's 1, 2 people, so that's 1, 2 dots. 1 sibling is 1, 2, 3, 4, 5, 6, 7, 8 dots. Let me do that a different color so you can see them. Okay, 2 siblings. There's 1, 2, 3, 4, 5, 6 people with 2 siblings. 3 siblings is 1, 2, 3. 4 siblings, there's no one. 5 siblings, no one. 6 siblings, 1 person. Okay, explain why you chose that model. Well, the model of the dot plot can shows us the mode and median, those measures of center. Using your data display, what can you infer about the number of siblings that most 7th graders have? Remember that word infer from last lesson was to make a statement, an educated statement based on what you see in the data. So I would say that most students have 1 or 2 siblings. Because you can see that cluster between 1 and 2, that was 8 and 6. There's 14 people out of our entire class that either have 1 or 2 siblings. All right, example number 1. Use box plots to compare populations. Finn and Jonah attend different middle schools. They compare the number of hours students at each school spend on homework each week. Finn and Jonah each conduct a random sample of 20 students who attend their schools, and then list the data in order from least to greatest. What can Finn notice about the time spent on homework? So step 1, display the 2 data sets in box plots. Remember, in the box plots, the lowest whisker is the least amount of homework. So the least amount of homework that both classes do is 1. And then the highest whisker, the farthest end on the right, is the most amount of hours of homework people do. So that's 11 for both schools. Then the middle number, the middle line, is the median. So the median for Finn's data set is between 3.5 and 6.5, so the median is 5. And the median for Jonah's data set is 7. So we can say that the median at Jonah's school is higher than the median at Finn's school. The median best describes the data because both data sets have outliers. Step 2, use the box plots to compare. I kind of already just talked about that, but let me read it for you. The line for the median of Jonah's data set is to the right of the line for the median of Finn's data set. So Finn can say that the median of Jonah's data set is greater. The box for Finn's data set is longer than the box for Jonah's data set. So Finn can say that his data is more spread out, has greater variability. So that's something I really want to talk about this lesson, is the fact of variability. Variability is how spread out the data is, how wide the options are for the hours. So if you see that Finn's data set goes from here to here, which is about from 3.5 to 6.5. So the box is 3 long. Then Jonah's data set goes from 5.5 to 8, which is only 2.5 long. So the box is bigger for Finn's data set, so Finn's has a greater variability. It's wider spread data. This is called the interquartile range. Remember I talked about this is Q1 and this is Q3. Range is the highest minus the lowest. So the interquartile range, or IQR, is always going to be quartile 3 minus quartile 1, which we did. 6.5 minus 3.5 to get 3. And then we did 8 minus 5.5 to get 2.5. So the IQR, interquartile range, helps us find variability. Let's try it. Kono gathers the heights of random sample of 6th graders and 7th graders and displays the data in box plots. What can he say about the 2 data sets? So the first thing we're trying to do is the median. So the median is 62 for 7th graders. And the median the median is 62 for 6th graders. And the median for 7th graders looks like it's between 62 and 64. So I'd say that's 63. So the median of blank grade sample is greater than the median of blank grade sample. So whichever one's greater is to the right. So the median of the 7th grade sample is greater than the median of the 6th grade sample. Now we want to find the one with the greater variability. Whenever you see that word variability, I want you to think about the interquartile range, IQR. So they both have quartile 1 at 58. 6th grade's quartile 3 is at 64. And 7th grade's quartile 2 is at 68. Now this is very easy to see which one has greater variability, which one has a bigger box, because they both start at 58. So the 7th grade sample has greater variability. There's more of a range in there. There's more of a difference in their heights. But if you weren't sure, you could always subtract. Remember range, we take the highest minus the lowest. 64 minus 58 is 6, and 68 minus 58 is 10. So 10 is in fact greater than 6, proving our quantitative inference that the 7th grade students have more variability than the 6th grade students. So how can you visually compare the data from the 2 samples that are displayed in the box? You can compare median, and you can compare the interquartile range. Remember, median is that measure of center. You're literally measuring where that center is. Median is a measure of center, and the IQR is a measure of variability, how spread out it is. Oops. Variability. Example number 2. Draw inferences using median and interquartile range. So Finn and Jonah analyzed the measures of center and variability of the data they collected. Do these measures support Finn's assessment of the 2 data sets in example 1? So number 1, the median of Jonah's set is greater, so the students at Jonah's school generally spend more hours on homework each week than the students at Finn's school. The interquartile range of Finn's data set is greater, so there is greater variability or spread in the number of hours in Finn's school spent on homework. I already kind of touched on this already, but another thing I want to bring up, excuse me, is that outside the box is both 25%, everything inside the box counts for 50%. So if you were to cut that box in half, each half is 25%. So you can always, excuse me, you can always look for the box to find your 50% of data, your majority of the data. Example 3, draw more inferences using measures of center and variability. Mr. Bunsen had students grow the same type of plant in 2 different rooms to test the growing conditions. The box plots show the heights of all the plants after 3 weeks. How do the 2 populations compare? What inferences can be drawn? So looking at box plots, you want to look at the median, and you want to look at the interquartile range. The median heights of the plants are the same. You can make the inference that the plants in room 7G are generally taller because the starting height and the ending height, the lowest height and the highest height in 7G are taller than the lowest and the highest in 7D. Looking at the interquartile range, we go from 8 to 14, so the IQR is 6 because we do 14 minus 8. Interquartile range for 7G, we go between 10 and 16. So subtracting 16 minus 10 gives us our interquartile range of 6. So the interquartile range for both of them are the same, meaning the variability is the same. So you can infer that the growing conditions in room 7G are more favorable for the plant growth than in 7D. Now we don't know that for sure, but based off of the fact that 7G, the whole data set is moved towards the right, I would say that based off of this data, it's more favorable. It's better to grow them in 7G. Try it. A local recreation center offers a drop-in exercise class in the morning and the evening. The attendance data for each class over the first month is shown in the box plot at the right. What can you infer about class attendance? Well, on the morning, it looks like we get 4.5 people. And in the evening, you get a median of 6.5 people. In the evening, it goes from 3 people to 12 people is the whole range. And the interquartile range is 5 to 8. Where in the morning, it goes from 2 to 8 people. And the interquartile range, 50% of the data is from 3 to 6. So I can infer that more people attend the evening classes. We can infer that based off of the data, based off of the median and the minimum and maximums. But I can also infer that based off of, what I think. I would prefer to go in the evening than wake up early and go before work as well. Key concept, you can use data displays such as box plots to make informal comparative inferences about 2 populations. So you're comparing 2 different things. You can compare the shapes of the data displays or the measure of center and variability. Remember, measure of center is median and the mean or the average, and variability is the range or the IQR, interquartile range. So the medians of the 2 data sets, and these 2 data sets appear to be the same. They both appear to be at 5. 50% of the values in data set A are between 4 and 7, and 50% of the values in data set B are in 4 and 9. So data set B has a greater variability. The length of the box, the IQR for data set B is greater than the length of the box, the IQR for data set A. So data set B has greater variability. All right, 7th grade, let's say it. I can draw comparative inferences about 2 populations using median and interquartile range. Have a great day.